You think Tesla changed the world? No, that was just the opening act. Because at this very moment, silently beneath the surface, something monumentally larger is taking shape. Something the competition has missed entirely, and chances are, so have you. You see the vehicles, the logos, the internet jokes. You assume that's the disruption. But what if I told you the vehicles were never the actual objective? What if the Model Y, the Cybertruck, even the affordable Tesla everybody's been anticipating are merely a smokescreen, a decoy concealing an engine, a network so enormous it doesn't simply shake up industries. It reconstructs how power moves, how production lines reason, and how labor itself is defined. Because while every traditional automaker is scrambling to replicate strategies from half a decade ago, Tesla in 2025 is executing a strategy nobody else can even comprehend. A 5-part blueprint that doesn't go head-to-head with car manufacturers. It swallows them whole, and once you grasp it, you'll understand we aren't watching an automaker mature. We're watching an entirely new civilization boot up. Before we lift the veil, go ahead and hit like and subscribe to DEXA. Trust me, you don't want to greet the future from the back of the crowd. This blueprint has 5 moves, 5 strikes. 1, the unboxed process, demolishing a century of assembly line tradition. 2, the 48V architecture, rewiring the nervous system, aimed at ignition. 3, the 4680 cell, the master key to cost and range, shattering the barrier. 4, end-to-end AI, the ChatGPT moment for driving, leaving fiction behind. And 5, Optimus, mounting that AI onto 2 legs, a machine with a mandate. Any single one of these upends the game, but all 5 combined, it becomes a fortress, an unscalable advantage. Today, we take the machine apart. We expose every layer. Ready to see what's underneath? You need to grasp something first. The most devastating weapon in Tesla's arsenal right now isn't a car, it's the factory. Musk calls it the machine that builds the machine, but that's not a catchphrase anymore. It's become reality. Enter the unboxed process. For 100 years, we've worshipped one god, Henry Ford's assembly line. You know how it looks, a bare metal skeleton, a body in white inching down a straight track, a slow, sequential procession. Bolt on the engine, bolt on the seats, bolt on the doors. But that entire system is fundamentally broken. It's a relic. Consider the inefficiency. The entire line crawls at the pace of its weakest point. One holdup, and the whole operation freezes. A complete standstill. You've got robots and workers performing an awkward, claustrophobic routine, wrestling for room inside a steel enclosure, trying to fasten a bolt without breaking rhythm. And the line itself, inflexible, unforgiving. Want to shift the model? Good luck. Retooling is a catastrophe. It's sluggish, it's bloated, and frankly, it's hemorrhaging money. So Tesla's unboxed method hurls that entire century-old concept into the furnace. Rather than one long, sluggish conveyor, the factory is structured into parallel processing modules. Picture it like assembling a Lego car. You'd never construct the frame first and then attempt to squeeze the tiny driver through the miniature window. That's absurd. You'd build the floors separately. The front block, the rear block, the cabin, and then at the very end you simply snap everything together. This is precisely what the unboxed process delivers. Picture this. In one corner of the facility, that enormous front gigacasting is receiving its motor, its suspension, its steering. Simultaneously, in another corner, the rear gigacasting is getting its own motor. And at that same moment, the central floor pan, which is the structural 4680 battery pack, is being assembled. The real breakthrough, unrestricted access. Workers and robots enjoy full 360 degrees reach. Installing a dashboard? Easy. No roof in the way, no doors blocking your path. It's dramatically faster. It's more comfortable to execute. Then, and only then, do these massive pre-built, pre-tested modules converge. The front, the rear, the painted side panels, all of them join to that structural pack in one conclusive step. The outcome? Tesla claims a staggering 40% reduction in factory floor space, a 25 to 30% surge in production velocity, while simultaneously cutting the cost of building the factory itself. This isn't a marginal improvement, it's an entirely new doctrine. And if you want to track this revolution, you need to be subscribed to DEXA. This is the only mechanism by which Tesla can realistically manufacture that $25,000 vehicle at high volume, and more critically, at strong margins. But here's the hidden truth. That unboxed approach, an entire modular strategy, is only achievable because of another Tesla breakthrough: gigacasting. Understand this. Traditionally, a car's underbody is an intricate jigsaw. We're talking 70, 100, sometimes even more individually stamped metal components. Every single one has to be laboriously welded together by a colossal body shop staffed with hundreds upon hundreds of robots. Tesla's Gigapress, a structure the size of a modest building, discards all of that. It casts the entire front or rear underbody as one unified piece of aluminum. That single innovation alone eliminates over 300 robots. It wipes out 600 plus welds. It liberates an enormous stretch of factory floor. The finished component is stronger, it's lighter, and it is, critically, astonishingly faster and cheaper to produce. That solitary gigapart is the Lego block on which the unboxed method rests. And this is the part that should make you smash that like button. While competitors are only now rushing to order their first gigapresses, they're already years in arrears, because Tesla isn't merely ahead in the machinery. It holds a multi-year lead in the metallurgy, the secret ingredient, that proprietary aluminum alloy that is tough, non-brittle, and perfectly suited for high-speed casting. That represents a deep, expensive moat. And for legacy manufacturers with their billion-dollar commitments to those outdated body shops, crossing it may simply be impossible. So you have the unboxed skeleton. Now it needs a nervous system. And for over 6 decades, the entire automotive world has been locked into a decaying standard. A 12-volt benchmark was conceived for primitive machines, a car with headlights, an AM radio, and maybe power windows. But today, your car is a supercomputer mounted on rubber, and that 12-volt framework has become a severe choke point. The problem is elementary physics. You know the equation. Power equals voltage multiplied by current. If you need more power, say for faster seat adjustment, or the advanced steer-by-wire technology found in the Cybertruck, you have to increase either the voltage or the current. And since the entire industry has been frozen at 12 volts, their only solution was to massively increase the current instead. The result: thick, heavy, expensive copper wiring to accommodate the heat and the load. We're talking about a wiring harness in a modern luxury vehicle that can tip the scales past 50 kilograms. That's over 110 pounds. Miles upon miles of copper wire. It's among the most complicated, costly, and manually intensive components in the entire automobile. And worse still, you hit an absolute ceiling. You simply cannot support the high power demands of tomorrow's systems on a 12-volt rail. Not efficiently, not safely. So what does Tesla do? They rewrite the equation entirely by transitioning to a 48-volt system, first deployed in the Cybertruck and now standard across their next-generation platform. They overturn the table. Think about the math. To deliver the exact same amount of power, if you quadruple the voltage, you can cut the current by 4. That is a seismic shift. A 4-fold reduction in current means you can deploy wiring that is dramatically thinner, dramatically lighter, and dramatically cheaper. And the energy lost as heat plummets by a factor of 16. The Cybertruck's wiring harness is a fraction of the mass of a conventional truck's. This trims costs, it sheds weight, which extends range, and it massively streamlines that unboxed manufacturing process we just unpacked. It is the key that finally unlocks the Ethernet data bus, where a single wire can carry both power and data simultaneously, obliterating the one-wire per function nightmare of the past. But here's the section that should send every legacy automaker into a cold sweat. And it's why you need to hit that subscribe button for DEXA. This migration to 48 volts isn't merely an internal modification. It is a shockwave detonating through the entire global supply chain. For decades, corporations like Bosch, Continental, and Denso have mastered the 12-volt universe. All those window motors, the pumps, the fans, every single one is 12-volt. By transitioning to 48 volts, Tesla has effectively rendered its entire components catalog obsolete. Suppliers now face the immense task of re-engineering, retooling, and revalidating everything from scratch. A company like Ford or GM cannot simply flip the switch. They are being held captive by a supply chain that isn't remotely equipped. But Tesla, having designed so many of its own controllers and components, in-house, can enforce the transition. Their vertical integration allows them to absorb the disruption, while their rivals remain shackled to a 6-decade-old standard, piling yet another layer onto Tesla's already overwhelming manufacturing and cost advantage. So your factory is agile, your car's circuitry is lean, but you still face a colossal obstacle: energy. The vehicle still demands a breakthrough to become accessible to everyone, and that breakthrough is the 4680 battery cell. The name is just geometry: 46 millimeters wide, 80 millimeters tall. But its architecture, that is the revolution. A conventional battery like the 2170 cells in a Model 3 has 2 tiny little tabs at opposing ends. All the energy must battle its way through these 2 narrow choke points. That creates gridlock. It generates enormous heat, particularly during rapid charging or hard acceleration. The 4680's tableless design is elegant in its brilliance. Rather than a tiny tab, it uses a layered spiral connection. This means the entire interior edge of the cell's foil becomes the contact. The path for energy is suddenly short, wide, and unobstructed. This single architectural choice fundamentally rewrites the cell's behavior. First, dramatically less heat. Second, substantially faster charging. With minimal heat to manage, you can pour power into the cell. And third, instant high output. This is the secret behind plaid-level acceleration. But that isn't even the headline. If you're getting value from this breakdown, hit the like button for DEXA, because the manufacturing process is the true game-altering revelation. It's a technique called dry battery electrode, or DBE. For 5 decades, the entire industry has built batteries the same way, through a wet slurry process. You blend the battery materials into a toxic liquid paste. You coat it onto a foil and then push it through enormous, football field-length energy-hungry ovens to bake it dry. Tesla's DBE approach stamps the active material directly onto the foil in dry form. No solvent, no moisture. No drying phase. You need to appreciate how extraordinarily difficult this is. It is the holy grail of battery production. It is the primary reason the 4680 ramp-up was so prolonged. The conventional wet approach is like rolling paint onto a wall. It's slow, but it spreads uniformly. The dry approach is like attempting to distribute a coating of fine powder perfectly across a surface, making it adhere, and doing so at machine speed. It's like trying to compress loose gravel into a flawless mirror. And as of 2025, Giga Texas is finally scaling it successfully. This method doesn't merely promise to slash factory floor space and energy consumption by a factor of 10. Internal documentation is already unambiguous. The 4680 cell is already less expensive for Tesla to manufacture than anything it could procure from external suppliers. This is the final cornerstone. Pair this affordable, high-output cell with a structural pack where the battery literally forms the car's floor, eliminating 370 components, and you possess the key. This is the only path to a $25,000 vehicle. It's the only equation that makes the Tesla semi-viable. So the 4680 cell is the heart. Now we arrive at the brain. Full self-driving. For years, FSD has existed in this perpetual state of promising, divisive, perpetually forthcoming beta. But with version 12, it underwent a transformation as fundamental as the leap from a flip phone to a smartphone. Here's the reality. The original FSD and every iteration preceding it was a mountain of hand-authored code, a sprawling, fragile, human-engineered rulebook. Hundreds of thousands of lines of C++. If the camera detects a red light, apply the brakes. If a vehicle is merging, compute its path. If it's a stop sign but a pedestrian is present and cross-traffic is cleared. This methodology is brittle. No human team can write a rule for every scenario the real world will produce. A stop sign masked by foliage, a construction worker waving you through a red signal. This is precisely why true autonomy has been perpetually almost solved for an entire decade. So with FSD v12, Tesla did the unimaginable. They erased it. They deleted over 300,000 lines of that C++ code and replaced the entire stack with a single end-to-end neural network. This new system was never programmed. It was educated. Tesla fed it millions of video recordings of its most capable human drivers and essentially instructed the AI. Observe this, learn to operate like this, and it absorbed the lesson. The system now takes raw visual input from the cameras and outputs steering, acceleration, and braking decisions. Photons in, commands out. This is the ChatGPT moment for physical intelligence. The AI is anticipating the next most probable driving action based on the totality of footage it has ever processed. It learned to creep forward at an unprotected left turn by watching humans navigate one, not by consulting a rulebook. And this system scales infinitely. To make it more capable, you don't recruit 1,000 engineers to craft additional conditional logic. You simply curate new challenging scenarios, feed them into the training pool, and rebuild the brain. But an AI is only as powerful as the data nourishing it and the hardware processing it. First, the data. With over 6 million FSD-capable vehicles circulating on public roads, Tesla operates the most extensive data harvesting operation in human history. Every time a driver intervenes, the system flags that footage clip, that challenging snowy left turn, and sends it to the data pipeline. Second, the hardware. You've likely heard of Dojo, Tesla's custom supercomputer, but here's the DEXA level update. Because as of late 2025, the landscape has already shifted. Tesla recognized that maintaining one massive standalone training computer in Dojo and a separate chip architecture inside the vehicles was inefficient, a bottleneck within the flywheel. So they are pivoting, they are now converging on a unified AI architecture. New silicon generations called AI5 and AI6 that handle both tasks simultaneously. They are constructing their next training supercomputer, what you might label Dojo 3, from the very same powerful chips destined for their future vehicles. This produces the ultimate flywheel, a doom loop for anyone trying to keep pace. Superior AI produces better FSD, greater adoption generates more data, richer data sharpens the AI faster, and their new unified computing platform spins this flywheel at a velocity and price point that no competitor can replicate. This is the one path that plausibly delivers true, full autonomy. And when it arrives, it unleashes the single most economically disruptive force imaginable, the robotaxi, a $25,000 vehicle that pilots itself around the clock and generates $30,000 annually. That is no longer a car. It's a productive asset, and one that will permanently reshape our cities and civilizations. If you want to witness that future materialize, make sure you subscribe to DEXA. So you have the brain, you have the battery, you have the factory. What do you do with the world's most sophisticated AI? You don't leave it sitting idle in a parking structure. You give it a body. This is Optimus. Forget the human in the spandex costume. That was the prologue. Understand that the Tesla bot is not a side project. It is not a theatrical gesture for shareholders. It is the convergence of all components, the logical culmination in human form. Consider the synthesis. The brain runs the exact same end-to-end neural network as the Cybercab. The AI that mastered a chaotic roundabout can master a warehouse floor. It's identical code. It's simply learning human world physics, balance, grip, locomotion rather than vehicular physics. The heart pulses with 4,680 battery technology. The musculature, the actuators, the motors, the power electronics, pulled directly from the Model Y and Cybertruck production lines. Optimized for efficiency, optimized for performance. And the body itself. How do you manufacture millions of them with that same unboxed, gigacasted, unrelenting precision we just deconstructed? The advancement has been unsettling in its speed. Generation 1 stumbled. Generation 2 walked. As of late 2025 is running. It is 10 kilograms lighter. It is quicker. It possesses hands equipped with tactile sensors refined enough to cradle a raw egg without fracturing it, and then lift a heavy power drill without losing grip. And this is no laboratory showcase. These machines are already active inside Tesla's own facilities right now, executing the tasks nobody wants, the hazardous ones, the relentlessly repetitive ones. That is phase 1. But you might wonder, why legs? Why the complexity of a humanoid form? Why not simply an advanced Roomba? The answer exposes the true magnitude of the ambition. The reasoning is straightforward. The world was built around us. Our staircases, our door handles, our shelving, our hand tools. All of it was engineered for a creature with 2 legs, 2 arms, and 5 fingers. A wheeled robot is imprisoned on level ground. It is inherently specialized. But a humanoid is universal. It integrates into our world as it already exists. We don't need to reconstruct civilization around it. It can master installing a car door today, receive a software update overnight, and sort your laundry the following morning. This is not a product, it is a programmable workforce. Musk is wagering on demand, reaching 10, perhaps 20 billion units. That exceeds 1 unit for every human being alive on this planet. An autonomous laborer available for a fraction of human wage costs. That is an economic force greater than the automobile, greater than the personal computer, greater than the entire internet. This is the end game. So step back, survey the entire board. Tesla's technologies aren't a collection of isolated gadgets. They form a single interlocking organism. The unboxed process constructs the machine. The 48-volt architecture wires the machine. The 4,680 cell energizes the machine. The end-to-end AI steers the machine. And Optimus takes that machine and equips it with hands. Every piece is a lock, and the next piece is the key. They are not trying to sell you a marginally superior electric vehicle. They are laying the infrastructure for the next industrial revolution. Whether this monumental wager ultimately pays off, or whether humanity is even prepared for what it unleashes, is the single most consequential multi-trillion-dollar question of our era, and we will be here to document every moment of it unfolding. Thank you for watching DEXA. If this video restructured your thinking, hit that like button and make certain you are subscribed with notifications enabled, because the future is accelerating and you cannot afford to fall behind.